So in this video, let's talk about the dot product. This is an operation that is performed on vectors. So we'd have a vector A, for example, dotted with vector B. Kind of a big dot, but this is the dot product. So let's just say that A and B are three-dimensional vectors. So they have AX, AY, AZ components, and so on. So this is how you write the dot product, or how you solve for the dot product. It's AX times BX plus AY times BY plus AZ times BZ. Now note it's no longer a vector. You see, we've sort of squished the whole thing together. We've got the x components multiplied plus the y components multiplied plus the z components multiplied. So the dot product takes two vectors but returns just a number, a scalar. So that's important. There's one other definition for the cross product, though. It can also be found in this manner. The magnitude of A times the magnitude of B times the cosine of the angle between them. Alright, now just note here that I usually write magnitudes like this, whereas other people may write them like this, but I'm too lazy. Alright, so that's the magnitude of A, magnitude of B, cosine theta. It's also equal to this definition, but they're both the dot product. So let's talk about how this can be useful. Well, this theta right here, the dot product is an excellent way to find the angle between two vectors, because if you know everything about the vectors, you know all their components, then you can solve for their magnitudes, in which case theta is the only unknown in the equation, in this equation here. So let's try an example. Let's say we have a vector like this. Oh, I don't know. Let's make something up here. Alright, let's say we have this vector and we want to find its angle to the z-axis. We can write the z-axis as a vector, turns out. Don't know if you've done that before, but here it is. The z-axis, it has a 0 x or I component. It has 0 j component, but it is pointing in the z, or the direction of the k-hat vector. So I'm going to put a 1 there. So this is a unit vector that points in the direction of the z-axis. So if we wanted to find the angle between them, well, we know that r dot z hat will be equal to the magnitude of r times the magnitude of z times the cosine of theta. And that theta is the angle we're looking for. So let's continue to solve, shall we? The dot product is defined as, at the top there, we'll plug in, we've got rx times z's x component plus ry times z's y component plus rz times z's z component. Maybe not the best notation, but you get the idea. So that's the dot product, and it's equal to the magnitude of r times the magnitude of z times the cosine of theta. We actually have a few zeros here, right? Z's x component is 0, and z's y component is 0, as we discussed before. So, continuing to solve, we'll just divide by this side by rz, this side by rz, and we get that r's z component times z's z component divided by the magnitude of r times the magnitude of z is equal to the cosine of theta. So let's go ahead and plug in values. Recall that to find the magnitude of a vector, it is the square root of its components squared. So we'll be putting that in on the bottom here. So r's z component is -7. Z's z component is 1. I'm going to go ahead and divide that by the magnitude of r, which is the square root of 5 squared plus 6 squared plus -7 squared, and also the magnitude of z, which is just a 1. If you do square root of 0 squared plus 0 squared plus 1 squared. You'll get a 1. And that is equal to the cosine of theta, or the cosine inverse of all this is equal to theta. Solving for all that, we get a theta of about 131.9 degrees. So that is a way that we can find the angle between any two vectors. In this case, we used it to find the angle between a vector and an axis, and you can write an axis as a vector. So there you have it.